Welcome to Cybersecurity Workshops and this Introduction to Network Concepts. So this lesson is from the CyberRange Cyber Basics module in the courseware repository. This is from Module 2, which is the networking module, and the first lesson in that module is this Introduction to Network Concepts. So some learning objectives for this session. We're going to describe a network. We'll talk about wired or cabled networks, then we'll talk about wireless networks, and we're going to compare those two things beyond the obvious wired versus wireless. There are advantages and disadvantages of each, and we'll talk about that. We'll talk about local area networks, wide area networks, and the internet. And then we'll become familiar with some network security devices. So here's the basic definition of a network: a collection of computing devices that communicate digitally using wired or wireless connections. So that definition is pretty straightforward. There are different types of networks depending on the size and the scale of the group communication system. So these terms, LAN, WAN, and internet, it's really a matter of the scale of the network. So a local area network is a small group of systems, usually numbering in the tens to hundreds, occupying a single office space, building, or home. So the term local is the key term here, right? So local network, and a home is a great example of a local area network, and we're going to take a look at an example of one of those in a minute. The next step up is a wide area network. So this is generally a connection of local area networks. Generally covers larger geographic area, contains many local area networks, and they can comprise hundreds to thousands of systems. So this is up a level from a local area network, and the wide area network can be, there are sort of multiple levels of it. So you might have multiple local area networks that are aggregated into a wide area network, and then you might even have multiple wide area networks that sort of create this larger wide area network. And then at some point you get to the point where you are an internetwork. And so this term internet comes from the notion of an internetwork, so multiple networks connected together. And now the sort of the capital I internet, that's this broad term that describes the global network of networks that we use for things like websites and other various uses. So the term internet is used to refer to large numbers of small networks connected together to form a larger network. And so when does a wide area network become an internet? It's a little bit fuzzy. It's not there's not a clear definition in terms of numbers of systems or numbers of networks that are aggregated. But generally the term internet these days is used to describe, again, this worldwide network of networks. So internet is the term most commonly used to refer to the global network of systems and devices that comprise the World Wide Web, and I'm sure we've all heard of the internet. So here's an example of a local area network, and again, this is what you see in many homes. Internet access is provided to the home by an internet service provider. So you'll hear the term ISP, internet service provider. So here in my example, the ISP is the cable company, and so we have a cable coming to the home, and that's connected to a device called a cable modem inside the home. And then an Ethernet cable connects the cable modem, in my example, to the wireless access point. So here we have an Ethernet cable connecting the cable modem to a wireless access point, and the wireless access point is what is providing the network access to the other devices, right? So the other devices in the home are connected to the wireless access point, or WAP, via wireless network connections. So this is what you see in many homes these days. You have a wireless access point, and then you have multiple devices connected wirelessly. Those could be computers, could be printers, could be smartphones and tablets, could be smart speakers and other Internet of Things devices. Could be smart TVs and our various streaming media devices, and nowadays there are generally lots of devices connected to a home's wireless access point, but this is a pretty common sort of a setup in a home. wireless access point, the WAP, the wireless access point, routes network traffic from each device through the cable modem to the internet. So when your computer needs to connect to a website, for example, that request is transmitted wirelessly to the wireless access point, and then the wireless access point is going to forward that request out through the cable modem out to the internet, and that request goes through the internet to the network on which the web server resides, from which you're requesting the data. Might be, you know, a news website like, you know, CNN.com, or it might be a you know, online retailer like Amazon.com. But that request is going to go to that web server that resides somewhere out on the internet, and then the response is going to come back through your cable modem, obviously, through that wired connection to the wireless access point, and then wirelessly back to the device. So some of the components that you'll see in a network, you know, my example was a home network, but there are obviously other local area networks in schools and banks and you know, other sorts of locations. Some of the different components you'll see are things like a network interface card, or a NIC. So a NIC is inside the computer, and it is the thing that allows the computer to communicate with other devices on the network. So here I have a picture of a network interface card, and this particular type of a card is what you would see inside of something like a desktop computer. So a large computer case where you could, you know, open up the case and you can see the motherboard, and there are different types of cards plugged into the motherboard. One of those cards is often a network interface card. You know, you see less of these types of network interface cards these days. Now most of the network interfaces are built into the device. So for example, your smartphone or your laptop, those all have a built-in network interface device. So you don't see this sort of separate device, but that network interface has to exist, or that computer or smartphone or other device won't be able to communicate on the network. Obviously, there are different types of network interface cards for wired and wireless connections, and you'll even see devices that have multiple network interfaces. For example, you know, you might see a desktop computer that has an Ethernet plug in the back where you can plug in the wired network, but it may also have a wireless network interface that allows it to communicate, so that would be two different network interfaces in that device. Another network component is a switch. Switches connect multiple network devices inside of a single local area network. So if you had an office, for example, that had multiple computers in it, sorry, my pen's acting funny, multiple computers, those might be all connected via a wired connection to a switch, and those allow those devices to communicate with each other. And then there's another connection that will go out to the next device that will allow the switch to connect to other networks. So a switch connects multiple network devices together to form a local area network, and then a router routes network traffic between local area networks and wide area networks. So a router is a device that connects networks together. So a switch connects individual computers to the network. A router connects networks together. And there are large core routers that serve as the backbone of the internet. So when we talk about the backbone of the internet, these are large routers owned by internet service providers like AT&T and Verizon Wireless and other service providers. And those are the large routers at various locations across the country that allow these larger networks to communicate with each other. So here's an example of a wide area network. So remember, local area network is a small scale network, multiple devices connected together. A wide area network is multiple local area networks connected together. And the example I use here is multiple home networks, right? So here are several homes. Each one of these homes has a local area network like the one we just saw an example diagram of. And if you connect multiple of these local area networks together, now you have this wide area network. So in my example here, individual home networks in a neighborhood are connected to a switch in the ISP. Multiple neighborhoods can be connected together via network switches and routers. So you have multiple networks connected together in various ways, forms this wide area network. Again, my example is homes in a neighborhood. This could be businesses in a downtown area, could be buildings on a university campus. So various kinds of scenarios would form this sort of a network. And so here in my example, I sort of step up a level here, right? So in my example, I had multiple homes connected back through, back to their internet service provider. And so in a scenario like a town, for example, you might have multiple, or you likely have multiple internet service providers. So you might have the local cable company who provides internet service to some people, and then you might have telephone companies that provides service such as DSL. That's a different kind of a ISP connection. And then you might also have something like a FiOS connection or a fiber optic connection. So that would be, potentially another internet service provider. So in a, in one geographic area, you might have multiple internet service providers connecting, into the local wide area network for the geographic area, and then those wider area networks are aggregated, and then there's a connection out to the internet. Okay, so the obvious difference between a wired and a wireless network is shown here. So here's my example of a wired network. I have a switch, and then I have multiple computers, and those computers are all connected to ports on this switch. And this example is a little bit messy. Normally, the way you would see something like this is in, for example, an office building where you have desks and you have computers or laptops on those desks, and yet you might have a wired connection that goes from the back of the computer into a port on the wall. And then that wired connection goes through the wall into a switch room somewhere, and the switch room would have these switches that have the wires coming in that connect the wall ports to the higher level network. So this is kind of logically what it looks like in terms of wires connecting computers to switches, but in reality, normally most of these wires would be in the wall, along with the electrical wires and etc. So it wouldn't look quite this messy. And on the right side here, we have a wireless network. So we have, again, a wireless access point connecting multiple wireless devices to the network. And it's important to understand that wireless networks always have to have a wire somewhere, right? So there's always a wire that's going to take the network connection back to the core of the network. So there's a wire connecting the WAP back to a switch or a router or whatever. So some differences and advantages and disadvantages between wired and wireless networks. So for a wired network, generally you're going to get better bandwidth out of a wired network. So that means you'll get faster upload and download speeds. When you're downloading movies or software, that's probably going to happen faster on a wired network, and that has to do with bandwidth, higher bandwidth. That means you can send more data more quickly through that wired connection than you can through the wireless connection. It also means you're probably going to have better experience if you are doing like video conferencing. A wired connection is definitely going to is generally going to give you better experience, because again, it's a bandwidth issue. You can push more data through that wired connection. A wired network is also not subject to interference by other wireless devices. So obviously there's a pretty significant proliferation of wireless devices these days. We have phones and our computers and our tablets and our just all kinds of different devices, and so that eats up a lot of wireless spectrum, and there are certainly cases where you might see interference between those different wireless devices. And in a wired network, that wireless interference is not an issue, right? But on a wireless network where you have multiple communicating devices, sometimes in very high density locations, that interference can sometimes be a problem. Of course, some disadvantages of a wired network: the cost of installation is high because you have to route all these cables everywhere, and installing them in the walls or however they're installed to make it so they're not just laid on the floor. There's obviously costs associated with doing that. They're less flexible, right? So if I have an office space that maybe I laid out for a certain number of computers, and now my business requires more computers in the office, maybe I have to do something to install more capability to plug in more devices. So there's certainly this loss of flexibility. And if there's a wire connected to my device, obviously it's very difficult for me to pick up my computer from my desk and take it into the conference room if I'm relying on a wired connection. And generally, wired networks are costlier to maintain and troubleshoot. And again, that has to do with wires that aren't easily accessible. So a computer might be having a connectivity problem, and that could be because there's a problem with a wire that's in the wall. Maybe a rodent chewed through the wire, or maybe it got somehow crimped or cut during some remodeling operation, and so it's much more difficult to troubleshoot those problems when you have these physical wires that you have to trace. So the wireless network advantages and disadvantages are largely sort of mirroring the wired network. Wireless networks are cheap and very easy to install. It's really nice to be able to just plug in a wireless access point, connect your wireless devices to it, and then start communicating on the network. They're generally cheaper to maintain for those same reasons. Extremely flexible, right? I can take my laptop from my desk into the conference room. I can take my laptop into somebody else's office, and I'm not having to worry about this wire following me around. I'm connected to the network wherever I am. Disadvantages, again, mirroring the wired network advantages. Generally, you have lower bandwidth, so that means a slower network speed. Frankly, those bandwidth speeds are getting a lot better on wireless networks, so we're that's not so much of an issue anymore. A few years ago, it used to be a huge issue. Now it's less of an issue, and I think we'll see these wireless network bandwidths continue to improve over time. But you still have this challenge where you have interference, and again, this gets down to the proliferation of wireless devices, and there's not a lot of spectrum available. There's not a lot of wireless frequencies that these devices can use because of laws around what different portions of the spectrum can be used for. And so when you have more devices on a limited amount of network spectrum, then you're likely to run into some interference. So that can be a problem. Again, particularly in high density locations where you have lots of wireless devices in a small geographic area. Okay, so now we'll go up a step. We've talked about LANs, we've talked about WANs. Let's talk a little bit about the internet. So the internet started in the 1960s when a handful of universities in California and Utah were connected as part of this project by the Defense Advanced Research and Development Agency, or DARPA. And this agency is now called ARPA, but very similar. It's a DoD agency that sponsors advanced research by colleges and universities and government research agencies. And what they wanted to do is they wanted to have this way for computing systems to communicate over long distances. And so prior to this, computers were relatively new. They sort of invented in the 40s and 50s, and there was just no way to connect these computers over long distances. There were some technologies that would allow for some kinds of local area networks, but the technology for long distance connectivity between computing devices just didn't exist. So this project was all about creating that sort of a functionality. The network quickly expanded to include the entire US, but really it was about connecting universities and research agencies. It wasn't people's homes, until much later. So I mentioned that here. The network is mostly used for electronic communications between university students and faculty, research center scientists, and government agencies. Okay, so through the 60s, 70s, 80s, that's really what the internet was used for. In the 1990s, though, we had a pretty significant change, and that's when the web server and web browser were invented, and we got this notion of the thing called the World Wide Web. So that was in the early to mid 1990s that happened. Some researchers in Europe actually developed this notion of the World Wide Web, and you know, the web gave you know, people in their homes a reason to connect to the internet. It was sort of the first, you know, what we call a killer app. You know, it was the first reason that people really thought it would be interesting to connect to the internet, and so that's what happened. And things certainly advanced extremely quickly to the point where now we have literally billions of devices connected to the internet, and those billions of devices include, you know, computers and smartphones, but also now things like, you know, automobiles and these cyber physical systems or industrial control systems. And then now we have smart speakers, smart TVs, just all kinds of different devices connected to the internet. So this is what it looked like back in 1969 when the internet was first created. Again, this is 3 colleges, and then SRI, a research agency. And so this was the ARPANET, the precursor to the internet. Four organizations connected back in 1969. And a lot of the important work on the early internet was created by these 2 gentlemen. So if you were to consider sort of the inventors of the internet, these 2 names come up a lot. You have Vint Cerf and Bob Kahn, and they created these TCP and IP protocols in the early 1970s. And you may have heard these terms before: TCP and IP, Transport Control Protocol, Internet Protocol. These are the protocols that make the internet function, and these were developed back in the 1970s. So these protocols still exist in very much a similar form that they existed back in the 1970s. You know, there's been some efficiencies added, some sort of improvements added to those protocols, but they're largely unchanged from the way they functioned back then. And so I bring this up because this is one of the reasons we have some of the security challenges we have in the internet today. You know, these protocols were created back in the 1970s, and really at that time, you know, the expectation was not that these protocols would be used for 40 or 50 years. The expectation was that these were going to be relatively short-lived, and they were experimental, just long enough to get this communication system working. And you know, like any research project, the expectation on the part of the researchers was that, you know, something better was going to come along before too long. Their work was going to be added to, modified, improved, and you know, and then something different would go forward. But that's not really what happened with TCP and IP. It just turns out that these were really well engineered protocols, and they did almost everything extremely well. So they're efficient, they're reliable, they just worked really well. The thing that they didn't do very well was secure the network, and again, they weren't designed to do that. And that issue wasn't really recognized until much later, and you know, so now it's just really difficult to go back and replace those protocols because again, they're used in billions of devices worldwide. So this is what the ARPANET looked like by 1982, so it's about 13 years later. Now it covers the entire country. There are satellite connections to places like London and Hawaii. So obviously this expanded quickly, and now we have something that looks kind of like this, right? So we have undersea cables all over the world. We have you know, these connections just, you know, in continents, and all the continents. So you know, this internet, this network of networks has really exploded around the world. Okay, we'll talk briefly about some network security devices. And the 2 devices we'll mention are the firewall and the intrusion detection system. And so a firewall is a network device that blocks network traffic based on IP address, ports, and protocols. And so these are relatively simple devices. They make some very simple decisions based on very specific data, and that is the network address of computing devices on the network and the ports that are used to allow particular programs to communicate on the internet. And so by being, since they're very simple, the rules are very simple and well understood, then you know, these can easily either allow or block traffic based on these very simple rules. So a network-based firewall is gonna block traffic in and out of the network, and your wireless access point actually does a lot of that in your home network. A host-based firewall is going to do that at the endpoint, so on the computer itself. So most operating systems these days have some sort of a host-based firewall. So Windows 10 or Mac OS, you know, those have a host-based firewall. And then lots of organizations use both. And again, in your home, you probably use both. You probably have a wireless access point that's doing some filtering, and then you have a host-based firewall on your Windows 10 computer that you don't even have to manage because Windows 10 manages it. And so, you know, by using both of those, you have this defense in depth, so that enhances the defense of your home network. And then you have an intrusion detection system. This is more complicated. This monitors network traffic and alerts security analysts of possible intrusion attempts. So while the firewall is simply using some very simple rules to allow traffic or not, the intrusion detection system is actually analyzing the network traffic and then informing somebody of a suspected intrusion, right? So that's somebody malicious trying to gain unauthorized access to data or resources on your network. And so here's where you might see these on a network. So in this diagram, I have the internet on the outside. On the inside, I have the internal network that you're trying to protect. So that's on the far right here. So the internet is connected to your, to the local network through this thing called an edge router. And then what you might see between that router and your internal network is this network firewall. And again, this thing is going to be looking at traffic. It's going to be classifying traffic based on some very simple rules around network addresses and protocols, and then it's either going to block the traffic or it's going to allow the traffic. So it's in line with the traffic going in and out of the network, and that could be happening on both sides. You might be blocking or allowing on either side. An intrusion detection system is generally it has a different function on the network. So here, it's a very similar example. I have the internal network here. I have the internet here. I have an edge router. I might even have a firewall sitting, right here. In my example, I don't, but now I do. I just added a firewall, and so that firewall is still doing the same thing, allowing or blocking traffic. But what this intrusion detection system is doing is it's not going to be blocking traffic. It's going to be listening to traffic on the network through something like a tap. And if it sees something that looks like an intrusion, it's going to inform somebody like a security analyst. And then the security analyst is going to do some investigation. And the reason that those intrusion detection systems are usually not just automatically blocking traffic is because a lot of those intrusion, a lot of the suspected intrusions are actually not intrusion attempts. They're actually legitimate traffic that just looks anomalous on the network, right? It looks unexpected. And so why would you have something like that? Well, some of these systems, what they do is they sort of analyze traffic for a while and identify what looks normal. And then if something abnormal happens, they're going to alert. And that same thing could happen, for example, if I added a new device to my home network. That would cause some traffic that looks different than the traffic before. So if I had an intrusion detection system, I might get an alert that says, hey, this new thing is malicious, when really it's just a new printer maybe that I added to my network. So the way these two devices function is very different, and the way they're used on the network is generally very different. Okay, so thanks for joining me for this introduction to networking concepts, and we'll see you next time for some more networking.